We are live, and we are live. And welcome to today's webinar. Wish everyone the happiest of holidays. And if you can hear me, please drop a note in our Q&A box to make sure that we are being seen and heard. I'm James Hickey, Managing Editor of RFIDJournal.com. I'm incredibly excited to be moderating and listening in on today's session titled Powering IoT and AI Data with Battery-Free Wireless Sensors. For this webinar, driving the bus will be Eric Beal and Jason Gill, two experts from Powercast, the 2025 RFID Journal Award winner for Best New Product. This webinar will dive into how Powercast battery-free wireless sensor technologies are feeding critical environmental data to artificial intelligence systems using existing infrastructure and hardware. For all of our friends watching right now and those that are new to RFIDJournal.com, welcome. RFID Journal is an online media company publishing daily news, a weekly email newsletter, and a rich menu of additional resources, including webinars like this one, and insights from industry experts, including a submission that we recently published from Powercast Dr. Charles Green as part of our ongoing series of 2025 reflections and trends for 2026 for all things RFID, AI, IoT, sensors, from leaders across all these spectrums. So if you haven't already done so, subscribe to our weekly newsletter by signing up at RFID Journal's website. And during and after today's session, please follow along and share your thoughts and feedback on our Facebook and LinkedIn media channels. And as you can see, all of our social media links and handles are on your screen. Now let's take a quick look at the platform we're going to be using today. The On24 console that you're looking at right now can be completely customized. You can move and resize windows, making the video or slides larger or smaller as is your want. You'll find an array of interactive tools in this experience. In the toolbar, you'll see a media player button that allows you to control your video and volume, a Q&A box where you can submit your questions, and we'll get to as many of those as we can at the end of this presentation, a resource list. You can click through this to download the slides and related resources provided by our friends at Powercast. And perhaps most important of all is the survey icon, which you can click to share your feedback at any point during the session. Your input is extremely important to us. So before logging off today, please make sure to take a moment to share your thoughts on ways we can improve future events. If you have any follow-up questions or need help with your experience, just press the help icon to get further guidance. Before we kick off the conversation, I just want to share a little bit about our subject matter experts today. Eric Beal, Director of Strategic Partnerships for Powercast, earned his undergraduate and graduate degrees in electrical engineering from the University of Pittsburgh. He specializes in PCB design, schematic capture, wireless communications, RF design, antennas, IP creation and analysis, business development, regulatory compliance, and mathematical modeling and simulation. His professional background includes extensive contributions to Class 3 medical device design, antenna RF and PCB design, as well as nano power electrical design. Eric holds multiple patents issued for medical device design and RF energy harvesting, with numerous pending applications in wireless power and RFID fields. He's presented at industry-leading conferences and seminars in the U.S. on topics ranging from RF inductive power transfer to defibrillator hardware architecture. And notably, Eric was the first co-op student to be hired full-time at Powercast, now is in charge of bringing the next generation of co-ops into the organization. Joining Eric is Jason Gill, Director of Research and Development for Powercast. Jason, who earned a bachelor's degree in electrical engineering from Penn State, has over 11 years of experience having held engineering positions in the automotive, medical, and RF industries. Currently, Jason is focused on the development of products in the area of antennas, RF, and low-power electrical design. He holds multiple patents in the RF harvesting field, which has contributed to increased performances across Powercast products. Additionally, Jason serves as the project lead on Powercast's new chip design efforts. We're in the hands of two really smart people and two experts on this subject. With that, I hand over the keys for this webinar to Eric and Jason.
Wow, what an intro. Thank you, James, for making us sound so good. I promise you, as serious as that sounded, we're pretty casual people here, and we want to take a second to just thank everybody, to the thousands in attendance here, to the millions who are going to live stream this at home. Thanks for joining us and giving us a chance to talk a little bit about Powercast, what we do, and some of our recent products here. That will lead us into our next, but most importantly, let's get something settled first. So James and Jackie, we were talking with them about this just before we started here, and we thought we needed to take this to the people a little bit here. What gas station do you prefer? We're based in Pittsburgh, so we're Sheetz people here. The other side of the state of Philadelphia is very heavily Wawa, and then towards the south you have Buc-ee's. So we're interested from the people. Tell us what you think here with the poll, because this is the real information that people want. Also, feel free in the comments to let us know why you feel that way. I'm sure Jackie would love to parse through the comments to really understand how people are feeling about this question. Okay. So we'll let you answer away on that, but I think we're going to dive into a couple of questions here, or I'm sorry, we're going to dive into a little bit of background about Powercast to start. Okay, so we got Sheetz out front by quite a bit. Okay, let me tell you a little bit about Powercast. So the way we structured today is we're going to tell you a little bit about Powercast, our history, get into 3 of our different wireless power technologies and how they work and how we use them. And then we'll get into the PCT300 device that won Best New Product for RFID Journal at the end with a case study with data on that as well. So regarding Powercast, so we started way back in 2003, and Powercast was actually spun out of the University of Pittsburgh, who was doing a lot of the initial research in the RFID field. And sort of the concept was every RFID tag you use today, at least in the UHF RFID universe, has a front-end rectifier harvester of some kind that's taking RF energy, converting it to DC power, and that's how the tag is basically operating, has the power to operate and backscatter data. So the concept that Powercast had was that power is there. Most tags only care about getting enough energy to run their internal state machine. But what if we could be efficient in that conversion and use that energy to do other things? So the idea of the whole wireless power at a distance was, can I harvest energy from RF sources efficiently to enable me to do things with it, right? So we've been in Pittsburgh, PA this whole time. Our patent portfolio has over 300 issue and pending patents, all surrounding different harvesting topics. And we like to think of ourselves as the world leader in deployed long-range wireless power solutions. And we'll get into our capabilities a little bit, but in the course of doing this, in our design work and integrating our technology into other people's products, we've come to grow our business to support full product design and manufacturing capabilities at scale in the millions of units. So we can do everything from sell chips, which we have available through distribution, to take a sketch on the back of a napkin and help you make it into a product that's manufactured in the millions and distributed worldwide. So pretty vast sort of capabilities there. So quick timeline, I don't want to bore you too much with the history, but like I said, we started back in 2003, and in 2010, we first offered our first transmitters and receivers for commercial purchase in the world. We were the first to do it. That was Part 18 approval. That first product was a Christmas tree, where transmitters were on the Christmas tree and the ornaments themselves were wirelessly powered LED lights. So anywhere you hung them on the Christmas tree, they would light up without you having wires run around your Christmas tree. An interesting, first deployment, but since then we've done quite a bit more. In 2018 was our first consumer-facing wireless power transmitter. And then by 2020, we were shipping our harvesting chips in the millions of units. There's plenty of different industries where our chips fit in, consumer electronics devices, medical, and that's where we started seeing a huge uptick in the sales of our chips. And then more recently, in the last few years, we added 2 new sources of RF energy technologies to our portfolio. The first one is short-range smart inductive technology. This is basically coil-to-coil inductive transfer technology that most of us are familiar with. We'll talk a little bit more about this. And the second one, the more recent one, is magnetic resonance, which is very exciting for us as well. So with that, I think I'll shut up for a little bit and let Jason tell you a little bit more about our first flavor of RF power.
Yeah, so as Eric talked about, we typically break the wireless power down into 3 distinct categories. The first one is where Powercast started. That's the RF energy. That's powered at distance using radio waves transmitter receiver up to 200 feet, typically tens to 100 feet away. The third one listed here is that smart inductive technology. That's, say, Qi, what your phone uses, coil to coil, like Eric mentioned. And then the one in the middle is magnetic resonance. And that's kind of more or less a hybrid between the two. It uses resonant coils. That lets you get a little farther distance than, say, the inductive, but a little higher power, a little more power than what you would get with the RF. So now we'll dive into each one a little bit and talk about those three different categories, starting with the RF wireless power. So as we said before, we at Powercast developed a chip that can convert RF energy into DC power. Those chips have a high conversion efficiency over a wide range. And why that's important is with some of this RF stuff, it is difficult to maintain a high conversion efficiency over a bunch of different parameters, such as, say, input power. So it's hard to get a chip to have high efficiency at minus 10 dBm as well as, say, plus 10 dBm. Also, different DC output voltages will affect that efficiency as well. So for a product that, say, could be moving in the field, getting different power levels, we need to make sure we can maintain that high RF to DC efficiency. Having said that, they are easily embeddable. So that picture you can see there has a couple of our products in it. You just need an antenna tuned to the frequency of your transmitter and the PCC110 chips, which are those RF to DC chips we talked about. Once you have that in your product, it enables you to do power at a long range. So in the lab here, and actually in our parking lot, we've done some testing where we can power some of these devices up to 200 feet away from our transmitters. That enables sustainability. So now in devices that, say, had a replaceable battery, you can switch to a rechargeable. And for some low power sensors, you can eliminate the battery altogether and go with a storage device such as, say, capacitors or something that will last the lifetime of that product. And it's very easily customizable. And we've done global regulatory compliance. So we've got these FCC certified, ETSI certified, basically you name it, and we've taken these through compliance.
Yeah, and the one thing I would say too that's not listed here is that the chips themselves are capable of harvesting from a wide range of RF sources. So any frequency between 10 megahertz up to 6 gigahertz, we can technically harvest from when you pair it with the appropriate front end and tune it appropriately. So we can harvest from Bluetooth sources and Wi-Fi sources. We can harvest from RFID readers, which is what we're going to talk about in detail and what we're doing a little bit later with this particular product. But those chips can harvest from anything from NFC all the way up to 6 gigahertz, the 5.8 band Wi-Fi.
Yep, and going hand in hand with that, we always get asked the question of, okay, well, what can you power and, say, at what distances? So as Eric was talking about the different transmitters, this example here uses one of the FCC certified transmitters that Powercast does offer. You can see that gray box there is an example of one of those transmitters. So what we like to say is, say, smartphone peripheral devices, headphones, smartwatches, earbuds is kind of a tabletop application, a couple of feet away from a transmitter, and it'll charge up. Some other, say, what we would call for RF higher power devices, such as a keyboard and mouse, can be up to 5-6 feet away. So the idea, you put the transmitter on your desk and you could wirelessly power your keyboard and mouse. And then after that, I would say comes IoT, smart home sensors. That would be door sensors, window sensors, stuff that is very annoying to go around and replace the batteries in, something that you just want to put there and forget it and have it last a lifetime of the device. And then at the far extreme would be some low power, low duty cycle, say temperature sensors, which we've done up to, like I mentioned before, 200 feet away.
Did you want to mention the wireless power calculator too?
That's right. So if you're curious about whether RF would be a good fit for, say, some application that you might have, on the Powercast website, we do have a wireless power calculator. What that lets you do is select from a range of existing products for the transmitter. So the Powercast product line for transmitters is there. You could also enter the parameters for a custom transmitter. And then same on the receive side, you could pick from a range of off-the-shelf antennas or a custom antenna that you have, put in all that data, click the button, and it'll tell you at the expected power you would see at different distances. So it's a nice way to see if it is a good fit for your product.
There's a link to it, I believe, in this presentation that everyone should get after this too. So it can take you right to that calculator if you're interested in just playing around to just see generally what kind of power levels we're talking about.
Yep.
And The industry applications, I mean, power is about as ubiquitous as it can get in terms of what it can go into. So for the application we're going to talk about specifically here, it was data centers, but retail, smart building, consumer electronics, healthcare. There's a ton of interesting ways that folks are using our technology. And a lot of times we get interest from things we've never thought of before. Just people coming up with different ways that they want to implement wireless power. So there's some pretty interesting applications, but like I said, not going to list all of these here. I think the most interesting one to note is in the picture there, you see a Samsung TV remote. If you buy a Samsung TV and get one of their smart remotes with it, our chips are in that remote. It basically was an initiative to go green and eliminate batteries from landfills. So those remotes do not have batteries, they have supercapacitors in them. And there are 3 ways to recharge that supercapacitor. There's a USB-C port on the bottom, so you can plug it in to get instant powering. There is a solar cell on the back side of the remote, so it can recharge from sunlight. And then our chips are in there that are harvesting from ambient Wi-Fi and Bluetooth signals. So if you have a signal strength that's high enough, we'll capture some of that energy and use that to top off that supercapacitor as well. So we can go on, Ross. So Jason touched on the RF portion that we're most known for. Now I'd like to touch on the other 2 briefly, technologies that we offer. And the newest one is magnetic resonance. So the way you can think of this one is, I always like to use a desktop as an example. You can see in the simple image there, you got a green bubble over your desktop. That's basically representing a magnetic field. So it's a loop of wire that comes from a generator and creates a magnetic field. And then any devices that have a corresponding built-in receive coil in them can harvest from that magnetic field. It's similar to the inductive charging that a lot of us are familiar with. They're built, the Qi chargers, things like that are built into cars and desktops and things like that now. But that is basically coil to coil inductive transfer, and there's effectively no distance, and it's relatively sensitive to alignment. You've got to be lined up on that coil for the inductor, yes. In this application, you get a great freedom of placement. So any of the devices there that are on that sort of desk representation, you can slide those around, you can pick them up to a certain degree. You have complete freedom of placement of those devices while still delivering significant amounts of power, up to 100 watts total for all the devices on that table there.
Yeah.
We'll be showing some examples of this at the Consumer Electronics Show in early January here. And we showed some of it last year as well, as it was brand new to us last year. But yeah, we had a phone device that was retrofitted with a coil, keyboard, mice, lamps, a laptop, the monitor itself, all of that was being powered from wireless power.
Smart home camera we'll have this year. One thing to mention with the smart inductor or the magnetic resonance here and the RF we talked about previously is it's a one-to-many or even many-to-many technologies. So one RF transmitter can power essentially any device that is in that field. And same with the magnetic resonance here. One charging coil around that desk will power multiple devices on the desktop.
And I guess now is as good a time as any to answer. I'd say it's probably the second biggest question that we get when we are at trade shows or talking publicly is this technology safe? And I always say the same thing, and that goes for the RF stuff, the magnetic res stuff, and even the inductive stuff. If you're comfortable using a cellular phone and talking on it, our technology is orders of magnitude lower in terms of the exposure, and they're subject to the same regulatory requirements that all the other electronic devices are subject to. So our transmitters are FCC approved or ETSI approved in Europe, and the magnetic resonance and smart inductive stuff, same thing, they're all FCC approved devices. So people get a little weird when they're talking about RF signals and things like that. But like I say, if you're comfortable using cell phones, this is orders of magnitude lower exposure there. So let's touch on the smart inductive. Again, the industry applications for the magnetic resonance, you could think tons of examples.
Yeah, one of the major things we're focusing on with this is kind of that ease of placement, reducing charging cables. Desk is a good example. I like to say a bedside table is a good example. End of the day, you can come home, empty your pockets, put earbuds, smartwatch, all that stuff down, don't have to plug it all in, and it'll all be charged by morning.
And we'll just touch on the last one briefly. This is smart inductive power, which is inductive power transfer. So most folks are somewhat familiar with this. You've got a coil in your charging base, you've got a corresponding coil in, say, your cell phone there. You set them together, it's like two halves of a transformer coming together, and you're transferring energy from one side to the other. There's power plus data in that. The data is mostly relegated to controlling the charging of that device, but it's maintenance free. There's no connectors. You can make hermetically sealed devices. It eliminates ports and gasketing for IP sensitive devices where you're trying to have a high IP68 rating or something like that. And it's flexible. You can do different power levels. Cell phones and whatnot are sort of in the 13-watt range typically, but we can do up to a kilowatt with certain systems we've had here for robotic recharging applications. And again, from a regulatory perspective, it's able to be certified for use across the globe. Couple benefits, small form factor. So you're able to do this stuff. It's just a couple of coils that can be highly customized into end devices. And it's very high efficient as far as the power transfer goes. It's simple from a regulatory perspective. There's no uniqueness to the certification process, and you can use mostly COTS hardware to design around. So it makes it pretty simple to do. And in the industry applications for this one, I mentioned a couple. Robotics is a big one. Drones and UAVs, we've had a ton of interest in. Again, medical devices, so instruments charged without connectors, those hermetically sealed devices. And through surface charging, that's a neat one too, where we can actually put a coil on one side of, say, a wall and power a device on the other side of a wall. We've shown a couple of examples of that throughout the years at various trade shows. Did we do a camera last year?
Yeah. Yep.
Doing magnetic or
through a standard wall stack up. Yeah.
Yeah. So we built a standard exterior wall with 2x6s and insulation and siding on it, and had a little mock-up and charged a camera through a wall just to show that it could be done. Okay. With that, I'm gonna let Jason touch on a little bit of our capabilities here.
Yeah. So what we realized early was, yes, we have this cool RF technology, and then like we've said, we've added the smart inductive and the inductive. But it doesn't always just selling chips satisfy all the customer needs. So from that, we developed what we would call a flexible business model. So we'll do everything from sell the chips with the reference design and let you incorporate that into the product yourself. We'll kind of do a middle of the road where we can handle the RF design or custom antenna design and help you put that into your product. And all the way to the other extreme, we'll do a full box build where we'll design the product from scratch and put your logo, put your name on it, and sell it as a finished good. So we like to do whatever we can to get one of our wireless power technologies into devices. And with that, we kind of had to develop what I would call a unique skill set here in-house. So like I mentioned, a lot of the RF devices need an antenna. And we get a lot of customers who either come to us towards the end of the development cycle or at the very beginning, but have a unique case where an off-the-shelf antenna might not work. They need a custom antenna. So because of that, we do custom antenna coil designs, rapid prototyping to get those into the customer's hands as quickly as possible. Typical hardware, software, mechanical design to go along with those. More recently, we've been getting into chip designs. We've had a couple of customers that wanted to do a little more customization around that RF to DC chip, for example. So we've done custom chip design with them. And then with all of this kind of comes the regulatory compliance. So FCC testing, ETSI testing, it can be a unique challenge sometimes. And if you don't have that skill set in-house, it might be difficult to get some of these products, say, certified, especially if you have, co-located radios. A lot of these might have Bluetooth communication. So we'll help with regulatory compliance in any way we can. And then, like I said, some of those full box build we do actually have CMs all over the globe that we use. So whatever one fits your business need best is the one we'll go with.
I'd touch on a couple more there too. And then taking it to productization and high level, high volume production, design for manufacturing. We've had a number of customers come to us that say, hey, we had this product design. They worked with an outside design firm, and here's the BOM. We want to have you guys help us make this. And we find when we start looking at the BOM, they've got an $8 USB connector in there. They're using a $30 microcontroller when a $5 one would do. So cost reduction and design for manufacturing efforts to get their overall cost down, and then how to fabricate that production line fixturing to verify it during its production, all of that kind of stuff. And that's done at global contract manufacturers, whether it's domestically here in the US, Mexico, Vietnam, China. We have partners that we use depending on where the end product might go, to sort of maximize the cost to the customer and save on the shipping logistics as much as possible too. Okay, thank you for bearing with us. That's sort of the background on Powercast a little bit. And now we'll get into the actual PCT 300 and a case study that we've done with it for data centers. And the whole sort of idea came about with us working with a company called Asset View. And they had a data center where they had a need for monitoring temperature and humidity in that data center. They had an existing infrastructure, which we'll get to in a second, that was very beneficial, but their requirements were that they needed high accuracy temperature and humidity, small form factor to make it not only impede airflow, but just to make it easily deployable and maintainable. It had to be mountable on their existing metal server racks, which when you're dealing with RF products, anyone who's done RF design knows that designing around metal can be a challenge. Had to have high sensitivity for easy readability with their existing RAIN RFID infrastructure. So they were already monitoring the assets themselves with an existing RFID infrastructure. And that's really where this was a great overlap with our technology, because you'll see the next to last bullet point there is battery free with zero maintenance. Well, how do you do that unless you're doing power wirelessly? So the idea with this PCT 300 was the power would come from the RAIN RFID reader infrastructure they have. Those are an inherent source of RF energy that we can harvest to power these sensor devices. And then we can use the same communication channel of the RAIN RFID readers to pull the data out of the devices themselves. You want to take this one, Jay?
Yeah, so this is what we developed with it. You can see there it's a relatively small ruggedized case, wirelessly powered temperature and humidity sensor. It has long-range wireless power harvesting that has those PCC 110 power harvesting chips that I mentioned. The temperature and humidity sensor, essentially one way to look at our technology is we can supply the power over distance and we can supply the communication. Any sensor that is low power enough, we can interface with our technologies and get that data across. So we selected basically an off-the-shelf temperature humidity sensor that met the customer's requirements and embedded that in this device. And one unique thing that we added was what we call the find tag feature. So say you had one of these sensors that was hotter than the rest. How do you know which one that is in the server rack, or if you have multiple server racks? So this allows the reader to activate an LED on that PCT 300, and that LED will start blinking, and it lets the user know, okay, here's that one's at the bottom of server rack 2. That's where the temperature problem is. And with that, it enables that sustainable, free, and especially maintenance-free device. So you don't need to go around replacing batteries over time, and you also don't need to install gateways and different stuff that would work with other types of solutions. So those were the requirements, and these are the specifications we actually came up with. EPC Gen 2 compliant, so it works with RFID readers. We need to maintain that RF to DC conversion efficiency to make sure we had data rates that were equivalent or better than what was the solution currently was. That 5 meter range, so you might be thinking a server rack's not 5 meters, why do you need that 5 meter range? Well, if it works at 5 meters, that means the sensitivity is good enough that when you do put it in one of these server racks, say you had it and there was reflections or you had a polarization misalignment or something like that, ensuring that it would work at 5 meters means that it'll work at 1 meter with slight misalignment. Also, we have plus or minus 0.1% temperature accuracy, 1.5% humidity accuracy. Again, that wide RF range of minus 16 dBm all the way up to 20 dBm. Frequency is 902 to 928. So this is currently for the US FCC market, but we are working on doing the ETSI 868 version as well. And what we do typically is, as that sensor readings come in, we put them into the user memory of the RFID chip, and then using standard EPC Gen 2 commands, you can get that data out and convert it back into temperature and humidity.
One thing I would touch on here too, and Jason alluded to it, is that we are a power company. So the sensors used here were off-the-shelf sensors. And so we're sort of sensor agnostic. So lower requirements devices or other sensing capabilities are also possible as well. That was just what AssetView was looking for in this particular implementation. And in general, in this industrial space, the two most common sensing needs are typically temperature and humidity sensing. We'll go to the next one. Okay, so operational benefits of such a system like this. The low no maintenance thing is probably number one, is you basically eliminate the need for battery changes. There are battery powered options available in the marketplace. Everything with IoT sensors in general, I think the number one problem comes down to battery life in general. Some of these devices last a long time, but if it is critical to a maintenance infrastructure, that is going to necessitate the need to roll a truck to change batteries. It's costly, it's a pain in the butt, and it's relatively hard to predict sometimes when those sensors will die, and you don't want to have downtime or false alarms from failing sensors. It's a fast installation with this one. Again, we're leveraging existing RAN RFID infrastructure where we'll show you in a second the sort of implementation, but each rack has a antenna at the top of it shooting down at a height of maybe 10 feet or so. And so it's one antenna per row. So here's the representation of it. The green boxes on the right there represent reader antennas that are fed from one or more RFID readers or antenna switching systems. And then you mount the tags, which are represented by yellow dots there, at a high point, a midpoint, and a low point on each server rack. And you gather the data from all of those tags from each of the antennas. It would be pulled out via the back end of the RFID system and then sort of aggregated in a piece of software that would look at all of the pieces of data coming back. If you can go back to the previous slide really quick. So the fast installation makes it easy. You can just see the antenna mounts on a server rack. You slap a couple of them on each rack, off you go. There's no wires, there's no pairing because it works with the existing infrastructure. And you're getting within 1 degree Fahrenheit of similar wired solutions that they had explored. So quick summary is that it's reliable, efficient, and it's accurate without any maintenance burden as long as the RFID readers are running. So it's ideal for long-term deployment in a data center where you don't necessarily have maintenance going on all the time.
So you might be wondering, okay, do they actually work? So what we did is we took a handful of these devices and actually did a 5-week trial at a university data center where we sent the devices to them, let them install them according to the guidelines we set up and run their whole test. You can see that box on the left kind of has some of the data there, and all that green, like we've been saying, all that green there looks a little boring, but that means everything's working the way that you want. So all the sensor tags we're reporting accurate temperature and humidity data. Some of the unique things that we actually found with this was because they had freedom of placement, they could kind of put these in the server racks anywhere they wanted, and they would still get energized and report the data out. They actually found some areas of the server rack that were actually hotter than what they had previously expected. So they found kind of a temperature gradient that they didn't expect to see, which was kind of a unique finding.
Yeah, what was it? The tops of the racks were warmer than the bottoms of the racks, which they didn't expect. So that was just something that they noticed, and in the data you could see basically tags that were placed at the top were sort of grouped together at one sort of temperature range, and tags in the middle were sort of in the middle, and then tags at the bottom had the lowest temperature. So you saw, like Jason mentioned, a temperature gradient over the rack, which was kind of interesting and not expected.
Okay, so the key takeaways from it were with no wires, no battery, and with high accuracy, we were able to deploy a custom PCT 300 solution into existing server racks that worked with their existing infrastructure. So temperature visibility where it matters. What this really means is because there's no wires, you can kind of put these tags anywhere in the server racks that you want to, maybe near a fan to make sure that you have constant airflow, or near a device that's critical that you want to make sure maintains accurate temperature. That we saw, which we thought was a pretty unique find, and streamlined deployment without wires. we actually sent these devices, like I said, to a university, and they were able to install them with ease themselves without us being there to do it for them. It reduced maintenance hours and reduced costs by eliminating batteries, and its product line is expandable to monitor even more critical metrics. So like Eric mentioned earlier, if somebody wanted to use these devices for, say, airflow or vibration or current draw, these devices are easily adaptable to other sensor types.
So we want to thank you guys for kind of walking through both Powercast's history and capabilities with us, and then an example of our actual product and its case study. I think we're going to open the floor up now for questions and things like that. So James, do you have anything to say?
I am back, and I was fully taking notes, fully informed as we're going along. You know, the things that stood out for me is the people have spoken about their preference between Bucky's Sheets and Wawa. All joking aside, I think the wide range of industry applications is really impressive that Powercast overlooks. And within the case study itself, the easiness that the antenna can be installed at the data centers was something I think that, you know, really jumped out at me and is of a real selling point for this. We have some questions, and we have some time for those. So are you guys ready?
Yeah, let's do it.
The first one is, what other functionality is available for the tag aside from temperature and humidity sensing?
Yeah, so that's a great question. The PCT 300s themselves were developed for a specific use case for these server racks. And like we said before, it had the existing RFID infrastructure, so it was very easy to develop those for that solution. That being said, say somebody else, even with server racks, has a different sensor they want, it would be an easy change to do that, as well as easily adaptable to different, say, form factors. Maybe you want something that works a little farther, and we could develop one that had a slightly bigger antenna that received more energy. But the core technology is there, and it's easily adaptable to different sensor types and different sensor applications.
Okay, the next question is, what other industry applications are there?
There's quite a bit. I think the biggest ones that we see and get asked about on a regular basis are IoT is a huge one. Anything that is a low power sensing device that has a coin cell style battery, non-rechargeable, is an opportunity there to potentially run that entire device off of wireless power. Cold chain is another one that gets brought up constantly. If something is being transported and needs to stay cold and you need to ensure that it stays cold, you can implement existing supply chain RFID technology to get data on temperature throughout the product's journey. And that can be done battery assisted or not. So we've done tags that are sensors that work with RFID technology, but are also rechargeable with a rechargeable battery from RFID infrastructure, as well as ones that are batteryless and work only when within, say 30 feet of an RFID reader. So that's the food safety and cold chain supply chain that we see interest in as well for other industries.
Yeah, and then for some of the other technologies, say like inductive, we've seen interest around, like we said, kind of like drones and stuff before. But a cool one we actually did was we've seen a pole cleaning robot. Say where you need the robot to be perfectly sealed so that water doesn't get in when you put it in the pole, but you still need to be able to charge it without a charging port that can cause an electrical hazard or even corrode over time. So a solution like that was perfect for the inductive type of wireless power.
Okay. We had some other questions come in, so I'm going to give credit to where the questions come from now during the presentation. Derek Allen asked, for the PCT 300, how far away were the RF antennas? Antennas, yes.
So I guess I probably should have made that a little more clear in the presentation. Each server rack itself already had an RFID antenna in the server rack. And what they had to use those for in the past is each, say, asset in that server rack had an RFID tag on it. So if you needed to know where a specific component was, you knew exactly what rack it was in and when it was placed and when it was installed. So because each server rack already had that RFID antenna in it, we were able to, like I said, use that as an existing infrastructure. So the distance would be the size of, the size of a server rack. So I don't know, 5 to 6 feet, something like that.
And just in general, from RFID sources that are typically 1 watt conducted to a 4-watt EIRP type antenna. Our ranges are 30, 50 feet, depending on the antenna configurations. And we have done our own transmitters are similar to RFID readers when it comes to in terms of output power. And we've done some use cases out to 200 feet, right, Jason?
Mm-hmm. Okay.
So it's a tailored solution depending on what your RF source is. For the Asset View PCT300 use case, relatively short range with antennas basically right at the racks, but we can go much further than that depending on what the use case is.
Next question, from Michael Coe. Is there a UHF chip that can have more than 26 dBm?
Yes. So the one we offer commercially, we sell the most of, is that PCC 110, and that one itself cannot go up to 26 dBm. But we have other solutions that we've developed and other stuff we've done where we've gone well above, say, 30 dBm for some of these certain applications. I think we've done one where we were doing 4 watts of RF wireless power in a very unique situation. So that would be roughly 36 dBm or so.
Yeah, to be clear on that, that was the harvester chip itself, and we were paired with a off-the-shelf UHF RFID tag in that application. Yeah, but we do have harvesting solutions that can get you input, that can take input powers of much greater than 26 dBm.
Okay, Eric Kovitz has a next one. How are most of these sensors applied to items?
Physically, the mounting system with the PCT300 had a bracket associated with it. Was it just stick on, like, right?
Yeah. For the PCT300, yeah, that was the example. For most of the other things, you can think of it as anywhere before where you could put an RFID tag for tracking, the off-the-shelf kind of label type RFID tags. If you could get enough power to that RFID tag to use it for inventory management, then there's enough power there for us to also harvest that energy and power a sensor.
Okay. And now for our last one. We have one more question. Can the sensors work in extreme temperatures?
Yeah, so we're working on specific tags right now that are working on in extreme heat. So there was applications for a certain customer where the extreme high temperature was very critical. So we developed a custom solution for them where we could sense that extremely high temperature while keeping the tag itself at what I would still call a high temperature. And the whole thing was able to work and take temperature readings.
What kind of ranges are you talking about there? Like, what's the tag temperature?
I think we were reading, do you remember what we were reading for the?
I know we've done 85C, which is a pretty high end temperature.
I want to say for the other solution, the temperature sensor itself was upwards of over 100C, but I don't think the tag itself was getting to 100C. I think that was more in the 85C range.
And not just on the tag side, but we have developed our own reader modules in the UHF reader space that were designed for high temperature that could work at 85C ambient temperature as well. So we've done both. We've done the tag side, high temperatures, in something, and we've done readers as well that were deployed in high temperature environments. So we've kind of have experience on both sides. So the short answer is yes. And the longer answer is it depends on the how high we're talking, but we have done that in the past, yes.
Okay. That is the time we have for the questions. If your questions were asked and we didn't get to it, we're going to hand them over to the Powercast team and they will reach out to you. I want to thank everybody for their time joining us today. It was a really informative discussion by Eric and Jason. It was really great. And answering those questions like they did just now off the cuff I've done a couple of these and it's really impressive how their knowledge seeping through. We want to thank all the attendees for taking their time during this especially busy season to join us today. Just a reminder, we ask for everyone to click on the survey icon to share your feedback on the session. Your input is extremely important to us. So before logging off today, please take a moment to share your thoughts to help us improve our future events. We'll have this session from Powercast ready for on-demand viewing very shortly. You'll find an email in your inbox when it's ready to go. And please share it with your colleagues so that they can watch it as well. Thanks again, everybody. Have the happiest of holidays and healthiest as well. And we will see you in the new year. Take care.
Thank you, everyone.